Hello guys, so this is yet another problem from Hackerearth's June circuit problem. This one is quite interesting one, and this problem, as you can see, it's still running, and I'm not gonna reveal this video until the contest is over. I'm just creating them now. So let me just quickly read the problem statement. It's a bit lengthy, but it is important to help you understand the problem statement first. So instead of reading all of this, I'll just explain what this means. So we are just given an array of some n elements which are a1 to an, and let's define a function f of x which is equal to summation of ai bitwise and x. So for a given x, we'll have this value which would be summation of all the elements bitwise and with this given x. So we need to find the number of different values of x for which this function x is maximized. For those who are not able to understand, I'll quickly explain in a moment what does this formula mean. And what we need to do is we need to find the number of different values of x for which this particular f of x is maximized. So yeah, for this is a function, so for a different number of x, for different value of x, we might get different values. And in some cases, so this, if you draw a graph of these different values of x, we might get some different values, some going up, some going down, and for some values we'll get a maxima, and we need to know how many such maxima that we can obtain, and that's what we need. That's what the answer is. But there is one more constraint, and the constraint is that the x should have exactly L number of bits set in its binary representation. So yeah, we need to find such count of x which have exactly L number of set bits in their binary representation. And there are certain constraints. The constraints are very important in certain problems where we have to play with the bitwise operations. I will show you in a moment why this is very important here. So L could be only ranging from 1 to 30. The number of elements that we can have is 20,000, and each element can range from 1 to 10 raised to power 9. And it is also there are one more note, is that if there are infinitely many such values for which we can get this answer, maximum answer, we need to print -1, and if instead we need to print the answer. And it is shown that with the given constant, the answer, if it is not infinite, would always be less than or equals to 10 raised to power 18. So these are the very important notes here, and that's why I found this problem very interesting. And let me explain you how did I approach this one. Alright guys, so let me take this example, and I'm gonna first explain what this question asked for. So if you find this bit irrelevant for you, you can feel free to skip this part and forward the video a bit ahead so that you don't feel bored. And this is for especially the beginners who are trying to understand this. So let me just explain what the problem statement asks. So we are given this array, for example, and we have this L equals to 2. What we need to find is number of such x for which this formula gives us the maximum result. Alright, so let me quickly explain you what do we need to do. Is we have 3, 5, 7, 1, 4, and we need to pick certain x which has only 2 bits set in this in its binary representation. So for example, I have listed a bunch of numbers in their binary representation, and that means if L is equals to 2, that only we can pick out of these which are listed, we can pick this one, or we can pick this one, or we can pick this one, because they are the only ones which have only 2 bits set in its binary representation. Of course we can have certain others as well, but for now let me just focus on to this one only. And so once we do this, what we need to do, we can pick, let's say for this one, as this is 3 in decimal representation. So what we are gonna do, we are gonna take bitwise and with 3 and 3, and then we will add up with the bitwise and of 5 and 3, and similarly we will find the bitwise and with 7, 1 and 4, and we would add that up. So we will get some result. Let's call it A. And then similarly we would do with this 5, and then we would do the same with 6, and we would say A, B and C. So as mentioned here in the problem statement itself, in this example, because this is the same example from the problem, that for 5 and 6 we see the maximum number, the maximum value for this f of 6. So basically we can say that for 5 and 6 we are getting the maximum result, and for 3 we don't get, we still get some result, but which is smaller than the ones we get 5 and 6. And so the answer for this one would be 2, because there are two different values. Now let's come back to the part when I said we don't want to pick some other ones. So what would happen here if, let's say for example, apart from this, if we are going to pick any other, so it would always be something like this here, or something like this. So this particular part is going to be, because the numbers here are only up to 7, so we are interested in only taking the ones which have 3 maximum at max 3 bits set here, because 7 can be represented by this one only. So if we choose, let's say, something which is bigger than 7 for x, then what happens is ultimately this bitwise AND is gonna make this 0, so we don't want to go beyond x here. So that's what, and that's why I had just had listed down all these numbers here. So yeah, so with this explanation I hope you might already be getting some idea on what could be one approach to solve this problem, is that we can just try to list down all the numbers from 0 till the maximum value in this array. Let's call it a max. And what we could do, we can find out the ones which only have exactly L bits. So for example, if we somehow find all the numbers which have exactly L bits, like 2 bits here and 2 bits in all the binary representation, then what we could do, we can simply try to go through this formula and find out the answer for them, and keep on storing all these answers. And somehow I mean, once we have stored all the answer, we can sort those answers and know how many of them have the maximum values. So that's one way, but keep in mind that the maximum value could be as big as 10 raised to the power 9. So that would be a bit a naive approach, and that is not gonna work for sure, because we'll have to iterate from 0 to 10 raised to the power 9 to build all these values. And for sure there would be a lot of such values which might have certain number of else whatever number of bit set is required. So in that case, this is, I mean, for sure this is not going to work out. So let's analyze it a bit further and try to find out the efficient approach. So to talk about the more optimized approach here, let me just show you what they look like in what this array look like in binary representation. So this is what they look like in their binary representation, and what we need to do, we need to find certain x such that 2 of its bit are set and rest of them are set to be 0 or unset. So what we do, what do we want in the end? We want in the end for the, when the summation of the bitwise AND of this x with each of these value should be maximum. So we need to build this x, and we need to build this in a greedy manner, so that let's say for example, if certain bits are set here, let's say for example 1 0 1 or 1 1 0 in our case, because we wanted only to have the ones with the 2 bit set, then we need to somehow choose this bit. And what makes us choose only these 2 bits set, and why not the other one, like this one also would be the answer, because this one is also potential candidate, but why only these 2 are the ones which are giving us the best result? So to answer this question, we need to understand what makes this sum largest. So if we choose this the position of set bit greedily, this is what is going to make our sum or the f of x maximum. All right, let me explain you how. So what are we going to do greedily is that we are going to try for all the position from leftmost bit to the rightmost, or from rightmost bit to the leftmost. And as we know that this x can be as big as 10 raised to the power 9, so which means that there can be as many as 30 bits. So this is equivalent to saying that 10 raised to the power is equivalent to 2 raised to the power 30. So what we could do, we can try to build x for up to 30 digits, and we can try to position or try to set every bit on one by one and see how much contribution each bit are going to give us. All right, so let's see how much contribution we will get from here once we choose the rightmost bit to be set as 1. So we know that there are as many as 1 2 3 4 such bits, 4 such values whose rightmost bit is 1, or the 0th bit we can say is 1, and how much value it will add is 2 raised to the power 0 multiplied by 4. So this will add I will call it a 0th bit. Alright, so 0th bit is going to give us these many values, these many contribution, which would be 2 raised to the power 0 is 1, so it will be 4. Now how much contribution the first bit is going to give us if we consider here. So first bit, there are as many as 1 1, so 2, let me just write here. So first bit is going to give us total 2 raised to the power 1, because this is first bit, and multiplied by 2. So we have two such values who has their second bit, or the first bit, if we consider 0 based, so the first bit is turned on, so this will also give us 4. How about the second? If we consider the second bit here, that means second bit in x is turned on. So what will happen here, because we are, I hope you are getting that we are doing a bitwise operation, so we have total 1 2 3 such values. So basically 2 raised to the power 2 multiplied by 3, so this is going to give us 3 multiplied by 4, that is 12. All right, so now we know that these are the contribution that we are gonna get if we turn each bit on here. And now let's for now just consider that we want to select certain x which has exactly one bit set in its binary representation. That is this example here. Here we were given the similar set of values. Instead of this L being 2, we have 1. So let me just take this example only. So we said that we want to pick certain x which has exactly one bit set in its binary representation, and if we consider the 0th bit, turning on the 0th bit, then we will get only 4 as a contribution. And if we turn on the second as well, the first bit, we will also get the same, but we can see that the maximum we can get is once we choose the second bit as turned as 1, and that will be this one. So, and this is the only one which we can get the answer for. So the answer for this particular case, where we have 3 5 7 and 4 and L is equals to 1, the answer is 4, and which is also explained here in this example, that for the second test case only 4 is the value which satisfies, that means which gives the maximum result. All right, how about once we were supposed to choose 2 values? So now we can see that the maximum that we can get is by choosing the turning on this second bit on. Now how about choosing the second because we said that we want to choose value x which have exactly two of its bits set as 1. So we fix that this one is going to give us the best result, so this second bit is fixed. Now out of first and 0th bit we can choose any of them, so because both of them are giving us the same amount of contribution. All right, so that's why here we have an option of choosing 1 out of 2. So the answer here is 2C1. all right, which is equals to 2. So 2 is the only answer here, it is fixed, so we have to choose this one, so there is no choice here. So the answer for case when we were to find the number of such values which maximizes the f of x, the answer is 2. So now that you've seen that it doesn't matter which bit is going to give us the most contribution or whatever contribution it is going to give, it just matters that how many such contribution values are there. So if we know that we would get 12 for three different values and 12 is the maximum, we would always try to first consume all the ones which are there, which are the maximum ones, and then we would go to the next maximum. So basically, to generalize our approach, what are we going to do is we first count out all the contribution from each bit and then store their value, and we store in such a way that we would count all this like the number of times each type of contribution is there. So for example, how many times we have seen 4 as a contribution, how many times we have seen 12 as a contribution, and so on. And in the end we are going to sort these contributions by their value, and then and depending on the count and the number of bits that we want, we can find out the total number of such values which maximizes. So let me just explain you or walk you through my code so that I can make you understand this better. So this is what my code looks like. I am here taking the input for each element, and as soon as I am reading this, what I'm gonna do is I will check starting from 0 till 30th bit that whichever bit are set as 1. Like say for example, in here we have seen that this is what our array looked like, and what we wanted to do is count how many of these values have 0th bit set, and then how many of them has 1 bit first bit set, and second, and so on. So this is what I am doing here, and this is the way you can check if the jth bit is set or not. And as our x can have at max 30 bit, because we've seen that the values here can be as big as 10 raised to the power, and so can be x. So I'm just checking for 0 to till 30th bit. Then once I have stored the count of each bits, like how many of them are set for each position, then I'm just finding out the contribution of each values. So this is the way I am doing. So this is what you can say is 2 raised to the power I. That means if you remember what we were doing to find the contribution for the 0th bit, it is 2 raised to the power 0 multiplied by the number of such values, and then for first bit 2 raised to the power 1, for second 2 raised to the power 2, by multiplying each by the number of such values which have their second or first or third bit set. Alright, so this is what I'm doing here, first finding out 2 raised to the power I, then multiplying it by the count, and this is what I'm doing. This is the place where I'm storing the count of such values. So we said that we want to store the count of such values. So for example, how many gives me contribution of 12, how many gives me contribution of 4. So for that I have a map which I'm using to store the count of such values, and then I'm as I said, what I want to do, I will try to go from increasing to decreasing order, going from 12 till 4 and so on. So in map, it's by default is stored as in increasing order, and we want to go do the other way around. So that's why I have initialized a reverse iterator. I hope you guys are familiar with the maps and vectors and all. If not, please let me know in the comment section below. I'll try to make a video on STLs, the standard template libraries for C++, and also you can find bunch of them over the other places. So yeah, I'll put some very good resources in the description below. So yeah, as I said, so I'll do a reverse iteration starting from 12, and now at any moment if I see the number of such values is less than the number of bits that we can set, so we can simply subtract. What happened here is we saw that we have total here we have exactly 12. 12 is exactly once, so and we wanted 2 bits, so we can simply subtract that amount of values from L. So this will become 1, this is 1, so we'll have exactly one more value to be picked up here. So L will become 1 after this. And then what is the answer? What's the case when the count of such values is bigger than the amount of bits which are left to be picked up? So what was the case here? That count of such values is 2. For the second type of value is 2. As we've seen, there are 2 such values which gives you the 4 contribution, and we only need to pick one more. Alright, so L is smaller now. So in that case, as we have seen, it will be 2C1, as here 2 is the amount of such count. So count is stored in RIT of second to 2C1. I have already pre-computed this because this can only range from 30. Yeah, we can have at max 30. So I have pre-computed all this. So choose R. So RIT of second, choose we need to choose L out of these values. So this is the way we can do that, and in the end we'll set this to be equals to 0. And once we have completed all of them and we are still left with some bits to be set, then the answer is infinite. Because let's say, for example, in this case, if we were to pick 5 such values, we can have infinitely many such integers here, where after choosing 2 bits from here, we could have chosen so many bits from here that they are countless. So in that case, so this is the way we can just find out that in that case we need to print -1. That is, if there are still some bits to be set and we are not left with any such values or any value which is going to give us any contribution, then in that case the answer is infinite, and otherwise the answer is whatever we have calculated here. So yeah, I hope I was able to help you guys, and if there is anything which is unclear, please let me know in the comment section below. I'll link the needed resources and the link to my code in the description. And yeah, thank you for watching this video patiently, and yeah, please check out my channel if you haven't already. There are a bunch of other similar videos that I've made from different platforms, and if you like my work, please do subscribe to it. Thanks.